All right, section 11.2, going to get a little bit more of the trig intro stuff. So when you were doing 11.1, whether it was the GeoGebra activity or the homework or the notes, you notice that there was the whole degrees and radians thing. So let's talk a little bit more about exactly what a radian is. So if I take on a circle, and I drew an XY axis on here as well, and I'm actually going to remove the Y. Oops, didn't do that. I want to remove the Y axis out of here. I'm just going to leave the X. So if I start here on the X axis and I take the length of a radius right here. Okay, so this, see how it's a little bit darker red there? And let's pretend that it's a string. And I start taking that length of string and I wrap it around the outside of the circle. Well, I can start making my way around, and eventually I'm going to run out of string. I'm not going to make it all the way around the circle. I mean, that should hopefully make sense that the radius on the inside is not the same as all the way around the outside here. So I would start kind of doubling it up. I take, here's be a length of one radius, and then I take another one, and I take another one, and I get over here to 180 degrees. It's not going to be quite, it's going to be a little bit more than 3 of those to get to this spot right here. It turns out that it's actually 3, oops, it actually is 3.1415, and so on of those. That hopefully number should be familiar. Okay, it actually takes pi radians to get halfway around the circle. And it takes 2 pi radians to get all the way around the circle. So, and if you do 2 pi, that's approximately 6.28. So that's where that comes from. That's what a radian is. So that's why when we have this here, this would be pi radians, this would be 2 pi radians. If I put my y axis back in here, like so, this up here, pi over 2 radians, because that's halfway to there. And between 1 pi radian and 2 pi radians would be 1.5 pi radians, or 3 pi over 2 radians around the outside. So again, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, so that's the relationship between all of those. So it takes slightly more than 6 radians, it takes 2 pi radians exactly, to get around the outside of the circle. Okay, so that's what a radian is. So it's just a different kind of measurement. All right, this concept is probably more than anything that we do here outside of the relationship between degrees and radians. This is probably the biggest thing that is going to continue on when you get into pre-calculus and later on would be reference angles. I don't want to say everything that we do is going to be reference angles, but a pretty good chunk of it's going to be. So what a reference angle is the acute angle from the terminal side of your angle to the x-axis. Okay, so whether you're, doesn't matter which quadrant you're in, if I were to go directly to the x-axis, what is the number of degrees or radians away from the x-axis? So a 50-degree angle in quadrant 1 is its own reference angle. That thing is 50 degrees away from the x-axis. But what if I go over here into quadrant 2? So if I have a 150-degree angle, because this right here is, oops, sorry, didn't mean to erase that, 180 degrees, that thing would be 30 degrees away from the x-axis. So the reference angle for that would be 30 degrees. So a reference angle, it's always going to be between 0 and 90 degrees. That's the angle symbol, sorry, and that's a less than sign. Okay, so a reference angle is always going to be acute. What we're going to end up using this for is to take and draw a right triangle, and we're going to do something with the sides on those. That's what we're going to end up using it for. Okay, so if you have a circle, this right here is going to be 45 degrees. The other red one over here in quadrant 2 is 135 degrees. This one is 225 degrees, and this one is 315. Now, I just rattled those numbers off, and eventually you'll probably have those memorized. But what each one of these things is 45 degrees away from the x-axis. So all four of these have a reference angle of 45 degrees. Okay, they're all different angles. You know, you're rotating into a different quadrant. Your terminal side will be in a different quadrant, but they're still all 45 degrees away from the x-axis, meaning the reference angle is all going to be 45 degrees. Okay, so when I draw something like this, and I have a 10-degree angle right here, I could draw three more of those that would all be 10 degrees away from the x-axis, with this one being 170, 180 minus 10. This one would be 190, 180 plus 10. And this one would be 350, 360 minus 10. All of those being 10 degrees away. All of them having the same reference angle of 10 degrees. Okay, so then what we're going to do is on the preceding slides here, the following slides here, excuse me, we're going to be doing sine, cosine, tangent, and those type of things. What you're going to notice is that when they have the same reference angle, they are going to have very similar sines and cosines. What's going to change is going to be the positives and negatives. But the numbers themselves, the absolute value of the numbers, if you want to look at it that way, would all be the same. Okay, jumping ahead a little bit on that. The main thing to know is that an angle would have three other similar type of angles by doing the reference angle from the x-axis into the other quadrants. Okay, so back whenever you first heard of sine, cosine, and tangent, you probably did something called SOHCAHTOA, where sine was opposite over hypotenuse and cosine was adjacent over hypotenuse and tangent was opposite over adjacent. And you know, those are perfectly fine to kind of keep in the back of your brain. But we're going to look at this from a slightly different point of view. We're going to look at it from x, y's, and r's. And the reason is when you learn this as a geometry concept, you just had a triangle floating somewhere in space. Well, now we're going to put that on an xy axis. So that means positives and negatives are going to play a role in that. You know, when you draw a triangle, the triangle doesn't have a length of -10. Okay, but in here, because we're going to be having a direction on that, we will have lengths that are going to be negative. So we're going to do this in terms of x, y's, and r's. X would be left and right, y would be up and down, r would be, if I were to draw a circle, the radius on that circle. Okay, the hypotenuse of the triangle is what it'll be as well. Okay, so sine is going to be y over r. Cosine, oh, and by the way, let me back up 1 second here. The angle that we're going to be talking about is going to be the one that is right next to the origin over here. So just like when we were rotating our angles over the last two lessons here. So we're not going to be dealing with this one up here. We're going to be dealing with this one down here, and this is going to be a right angle. Cosine, x over r, tangent, y over x. Okay? We're going to have three other trig functions as well. They're going to be the reciprocals of these. So sine's reciprocal is going to be called cosecant. So that's going to be r over y instead of y over r. Cosine's is going to be secant. Let me write those words out here. So we got cosecant. This one was just secant. And then this one, I'm sorry, that's going to be r over x. And then tangent's reciprocal would be cotangent. Please don't say cot or sin. Okay, sine, cosine, tangent, cosecant, secant, cotangent. And those are the ratios. Okay. Now it's great if you memorize, these over here, but if you know that sine and cosecant are reciprocals and you know sine, all you gotta do is take it, flip it over. So however you need to go about knowing these. So these three are the big ones, because the other three you can sort of kind of figure out by just knowing what matches with what, and flipping will be the trick with that. Okay, this is what we're going to do quite a bit of you will over the next couple of years with this and with pre-calc. All right, so before we get into a lot of the stuff with sine, cosine, and tangent. Let's talk about a couple of special right triangles. So you have a right triangle with a 30-degree angle, which is going to make this then a 60-degree angle up here. And if this is 45 and this is 90, this will be 45 up here as well. So this is a 30, 60, 90 triangle. And this is a 45, 45, 90-degree triangle. Okay. So in a 30, 60, 90 triangle, the ratios of the sides work out as x, x square root of 3, and 2x. So that means the side across from the 30, if you double it, that'll give you the side across from the 90, or opposite would be the proper word on that. And then if you have the 30, the side opposite of the 60 would be that number times the square root of 3. So for instance, if this side was 5, then this side would be 10, and this side would be 5 root 3. This ratio will hold up no matter what the numbers are. So if I change this from a 5 to a 15, this side would be 30, and this side would be 15 root 3. But if I write if I do this side over this side right here, 5 over 10 is the same thing as 15 over 30. Both of those ratios are still 1/2. So the ratio of the sides is going to always end up being the same. So that's why we write it as x, x root 3, and 2x. For 45, 45, 90, x, x, x squared root of 2. Now, hopefully it makes sense why those two things are the same. When you have two equal angles, hopefully you remember that from geometry, that you have two equal sides as well. So if this side was 10, that would make this side 10. That would make this side 10 square root of 2. And if this side was 100, this side would be 100, and this side would be 100 square root of 2. So we're going to use that idea on our angles here. So what you're going to notice is that what we'll be doing a lot of here is this angle here is 0. This is 30, 45, and 60, then 90. This is 120, 135, and 150, which are 60 degrees away from the x-axis, 45 degrees away from the x-axis, and 30 degrees away from the x-axis. And then I'm going to do the same thing over here. 210, 225, 240 are 30, 45, and 60 degrees away from the x-axis, and the same thing over here in quadrant 4. So we're going to do a lot based off of these numbers here. Okay? All right, so let's do them. All right, cosine of 120 degrees. All right, so here's the process for doing something like that. So 120 degrees is going to be over here in quadrant 2. So what I'm going to do is I'm going to draw a triangle straight down to the x-axis, making a right angle right there, finding the reference angle down here. So if this is 180 and that's 120, that's going to make that 60, which would make this 30 right here. And then I'm going to write a ratio of sides. Now, I'm going to use numbers. You can use variables if you want to. I am going to designate one of the sides as 1. Okay? I'm going to call the side across from the 30 degrees 1, which would make the side across from the 60 degrees 1 square root of 3, and the side across from the hypotenuse, or the side across from the 90, opposite of the 90, would be 2. And I'm going to show you why it doesn't matter whether I start this side as 1, 2, 10, 50, a billion. It doesn't matter, because the ratio will still work out to be the same. So when I want to do cosine, cosine was x over r. Now, I have these here as my 3 sides. I have to worry about positives and negatives. Anything that goes to the left is going to be negative. Anything that goes to the right will be positive. Anything that goes up will be positive, so that'll stay positive. If it went down, it would be negative, and the hypotenuse is always going to be positive. So if I do x over r in this one, that would be negative 1 over 2, so negative 1/2. So let's say instead of making that side a 1, let's say I made that side a 5. Then this side would be 5 square root of 3. This side would be 10. That would be negative because it goes to the left, and that would be negative 5/10 for x over r, which still reduces to 1/2. What if instead I called it x? So this side would be x, this side would be x squared to 3, this side would be 2x, x over r would be x over 2x, and x, oh, I'm sorry, that would be negative x because it goes to the left. Negative x over 2x would still be negative 1/2. So any one of those that you would do would be negative 1/2. All right, let's do the next one. Tangent of 5 pi over 4. We're going to get into a lot of should you convert something to degrees or not. I'm going to convert this one to degrees just to show you, okay? So if you convert 5 pi over 4 to degrees by doing the whole d over 180 equals r over pi, like we did in the last section, this is going to be 225 degrees. So here's 225 degrees. 225 degrees is 45 degrees away from the x-axis. So we have a 45, 45, 90 triangle. So I'm going to label these sides as 1, 1, 1 square root of 2. Again, I could have done 2, 2, and 2 square root of 2, or 5, 5, and 5 square root of 2. X, x, x square root of 2. This one goes to the left. This one goes down. Hypotenuse is always positive. Okay, so the tangent 5 pi over 4 would be y over x, which would be negative 1 over negative 1, which would be 1. So the tangent of 5 pi over 4 would be positive 1. All right, sine of 90 degrees. Okay, here's 90 degrees right up here. And you say, well, how the heck am I going to draw a triangle for that? All right, so this point here would go left and right, 0, and up and down a particular amount. Okay, let's say that amount is 1. So let's give this point here the coordinates 0, 1. If I were to draw, I know you wouldn't do this, but let me show you something funky here for a second. What if I drew a triangle like this to represent that 90 degrees? Wouldn't this length here be 0? You'd go left and right 0, and then I would go up 1. And if I did Pythagorean theorem, 0 squared plus 1 squared would give me 1. So that would mean the up, the y, and the radius, r, would be the same number. Okay, so for 90 degrees here, x would be 0, y would be 1, and r would be 1. So when I want to do the sine of 90 is y over r for sine, which would be 1 over 1, which would be 1. Whereas cosine of 90, which is x over r, would be 0 over 1. So that would be 0. If I asked for tangent of 90, that would be y over x, which would be 1 over 0, which is undefined. Okay? All right, last one here. Negative 390. 0, negative 90, negative 180, negative 260, negative 360, or negative 270, I'm sorry. I think I said that wrong. 0, negative 90, negative 180, negative 270, negative 360. 390 would just be a little bit past that. And if this is negative 360 and that's negative 90, this would be 30 degrees. So again, I have a 30, 60, 90 triangle. Side across from the 30, I'm going to make that 1. Side across from the 60, I'm going to make that root 3. Side across from the 90, I'm going to make 2. That goes down, so it'll be negative. That goes right, so that stays positive. That's my hypotenuse, that stays positive. So sine being y over r would be negative 1/2. All right, that's section 11.2. Let me know if you have questions.